and then that minor correction is to be achieved through a closed loop system. So only closed loop will have this disadvantage, that if you are not looking at sun at all, you can get another point, let's say from the back reflection of earth, you can get another point where both the LDRs are receiving same intensity, but that thing is not as high as looking, even mislooking at the sun towards sun. So that is the first disadvantage of closed loop system, but the combined approach, that is open plus closed loop, can overcome that. Second disadvantage is, assume that cloud is there and it's moving. This is your sun and this is your panel. So now if I put my system response, T response, as very high, let's say 10 milliseconds, you can assume this panel will be continuously moving towards left, right, left, right, left, right. It's like a cycling in on-off controller, because you are putting a feedback, that is sometimes the shadow will go here, sometimes the shadow will go here, and this unnecessary moment, although we are trying to follow the maximum tracking, that is maximum light intensity, but this unnecessary moment is consuming all your energy. You are wasting the energy in tracking when it is not needed, and that is the second disadvantage. So the main concern to avoid this disadvantage is keep your TR as high as, let's say, 10 minutes. If 10 minutes nothing happens, you can follow the open loop location, otherwise move your panel to the closed loop. So basically your on-off timer will spread, that is, this duration will become now 10 minutes. So why I said on-off timer or on-off controller, because your panel can have only two directions, either go to the left or go to the right, and that is a cyclic problem with the on-off controller, which is very easy to implement controller, and hence we go for a controller called as PID controller, where P is the proportional response to the error, I is integral response, which is for the constants, and D is the derivative response, which is for the speed, and combine KP, KD what we call, and KI, combine three parallel responses will be computed, and then combined response is called PID response. So this is how, depending upon your input error, that is, you are not looking at the sun or maximum intensity point, you can compute the direction left or right and watt amount. So this watt amount X is the new factor, where in on-off controller you will having just 1 degree left or 1 degree right. So here you can go X by 15 degree to the left or maybe 7 degree to the right, and that is the advantage of PID controller. Next, what we propose is artificial intelligence. Now this artificial intelligence is nothing but a code which has a for loop. So it's very complicated term but very easy to implement. What we are doing, we are monitoring it for next 30 days. We are computing our own errors. So now we know I could have got 106.3 watt power, but I actually got 105.7 watt. So now you can calculate the error, daily error, what where you were missing, and depending upon this 30 days you can exactly say where your panel should be. So there is a concept of MPPT. For this AI to be trained, one day your panel has to be in monitoring at, let's say, fixed theta and fixed phi. So you have to say 1st Jan theta equal to, let's say, 0, phi equal to 0. Similarly, there could be another panel where theta is 1, phi is 0, blah blah blah, theta is 180. So this is the AI training set. So AI training set will tell me for 1st January what is the optimum theta, optimum phi. This is the initial feed for your AI. Now what we are doing, at this theta and phi we will plot this graph V versus I. This is current, this is voltage, and we will track down the maximum power point. And now we will follow a three-way approach. First is open loop system, which will give me the sun's position depending upon what latitude, longitude I am on. Second is closed loop approach, where we try to see the maximum intensity coming. And third, that is with AI, we will see for a month what was the mistakes we have done, where is the MPPT, and where should have been. So depending upon all three decisions, we will make a final decisions. Let's say this thing says 18 degree the panel theta should be. Let's say closed loop says no, it should be 19 degrees, and with AI and MPPT it is 18.5. So either you can average the three, or you can give a weighted, that is AI should have more weightage than a closed loop, and then a decision of your open loop. So this could be a priority based decision. Generally we take an average decision out of three. And the complete system what we try to propose is a big panel with a small tracking system beside it. This small tracking system will have a tray of LDR in 2 dimensions, so total 4 LDRs to track out the maximum intensity point. We will have a MPPT measurement system, that is voltage reader and current readout system, and a product V into I, that is done through a DSP or a microcontroller. Then you have a closed loop ADC system to it, and a powerful microcontroller such as Atmega, or even further powerful microcontroller such as SAM, which is ARM Cortex processor, to compute the open loop location of the sun. And everything is then connected to a big panel, big servo. This is a power driver. There could be a PLC in between. There could be a relay driving mechanism, optical couplers, etc. And we will try to move this 10 kilowatt panel, and I guess the voltage rating is around 28 volts or something like that, and it will be in tons. So to rotate any weight of 10 tons or something like that, you must have a mechanical load releasers such as ball bearings, which will take all the load. All you have to do is just to rotate that thing. So the mechanical coupling is required to take this 10k panels. And MPPT is basically, you have, whenever you have multiple panels, this will have a different maximum power, this will have different. So maximum power point track is the point where all the panels combinedly give the maximum power. So we should have individual panels connected together. Depending upon you want to increase the current, you should connect two same voltage panels in this manner, that is 12 volt 10 volt. And if you want a voltage rise, you can connect two 6 volt panels in series. So this becomes 6 volt plus 6 volt, 12 volt, and this becomes 1 ampere plus 1 ampere, that is 2 ampere. And this is how the complete system will work.